Okay, what we've done here is we've taken our main shadow stick and we have taken two readings 1 hour apart, one at 4 o'clock in the afternoon, one at 5 o'clock in the afternoon. And most survival manuals would have you believe that if you lay a stick across those two stakes and then another stick at 90 degrees to that you would have a good east, west, north, south line. We're going to lay a compass on here and I'm going to show you that you are about 30 degrees off of north with that method. And the reason for that is to get a good east-west line, you really need to take those readings one on each side of the zenith, which is the southing. When the shadow's over here at its shortest, in front of the shadow stick, that's the zenith. You need one on one side and one on the other side of equal length. All right, equal length is important. So I've got two sticks here that are equal length. And what we're going to do is we're going to take one of those sticks and we're going to lay it here across our last shadow line. And for now, it doesn't really matter, okay? And it's moved about a few degrees, but it doesn't really matter that the stick is longer than the shadow was, which is where the stake is, because both the sticks that we're using are the same length. So we are inferring the shadow length, all right? Follow me on this. Now, what we're going to do is we're going to figure out what our distance is of 1 hour of sun movement. If I put my feet in here, that distance is about the width of both of my boot toes. Right there, I can put both my boots between those stakes, and that pretty much does it, okay? And now what we need to figure out is how many hours are we after the zenith? Well, we know it's 5 o'clock, and we could count hands down if that's what we needed to do and we didn't have a watch. But for this demonstration and what I want to show you, it is 5 o'clock, so it's 5 hours after noon, assuming the zenith is about noon, which again is an assumption if you're on daylight savings time, but it will work for this demonstration. So if we're at 5 hours after the noon time, then we need 5 hours before the noon time, which we do not have. So how are we going to do that? Well, 5 and 5 is 10, and this represents 1 hour. So what we're going to do is we're going to pull this stake out of the ground. We're going to take a longer stick, and just as a guide, we're going to kind of lay it here on the ground for now. Then we're going to take our equal length stick that we have and take it in our hand here. And we're going to start at this stake, and we're going to measure over 10 hours. 1, 2, 3, 4, 5, 6, 7, 8, trying to stay in a semi-straight line here, 9, 10. Now what we're going to have to do is we're going to turn our feet without moving them toward the stake so that we can then take a long stick that will reach all the way across here and go from the stake to the edge of our boot here. And then we're going to lay our equal length stick right beside that here, just like this. So we have our long stick that goes to our boot, and we have our other stick in place, and now we can move the long stick out of the way. And this now represents an inference of two shadows the same length at two different times of day. So if we lay this longer stick across the two this direction, what we need to accomplish now is we need to accomplish a 90-degree angle here, and this 90-degree angle has to be a 90-degree angle on the other side. So what we need to do is we need to make sure that we have got this stick an equal distance here as it is here. So if we're going to put this thing about on the end down here, and then we need to put it where it would be on the end down here if it were long enough. Okay, and that's pretty close. Those would intersect if this stick was longer. And then from that, we need to line this stick up so that it is forming two 90-degree angles here, okay? And that's really important. It has to be a 90 here and a 90 here. So this triangle has to match this triangle exactly. Once you have managed that trick, then you have accomplished this. You are 7 degrees off to the east, and our magnetic declination here is about 7 degrees west off, and our magnetic declination here is 7 degrees west, almost exactly. So you really have right there a true north-south line at this point, and all you did was infer the angles by how many hours on each side of the zenith you were. Again, we started here, and we knew that we were 5 hours after noon, so we counted over 10 hours across, laid another stick down of equal length here. Our stick wasn't quite long enough, but it's even with the end there, touching the end there. It might be a couple degrees difference if you moved them a little bit. But that gave us a really, really close north, south, east, west line compared to being 30 degrees off had we done it the way it's explained in most survival manuals. So one thing we need to remember with this method that we use just now in navigation is all primitive navigation is approximation. It's never going to be exact. But as you can see, that was really, really close. Now, the key to that whole thing is that we did all of that with one stick in the ground. In other words, we could have walked up here late in the day after the zenith, or really any time after the zenith, a couple hours after the zenith to 5-6 hours after the zenith, depending on how much daylight we have. And we can infer the second angle in a couple minutes and have a really good line. Or we can wait 1 hour, put a stick in the ground and be who knows how many degrees off, depending on what time of the year it is, how deep the arc of the sun is, because it's only going to be a straight line one time a year at 23.5 degrees latitude. We're at 40 degrees here in Ohio, so we're never going to have a straight line. It's always going to be an arc. So having one shadow on equal distances each side of that arc from the center is what's the key to getting a good east-west line. We could have taken one shadow stick this morning at, say, 9, 10 o'clock, and then another one at 2, 3 o'clock, and we would have had a fairly straight east-west line because we would have gotten two shadows of equal length on each side of the zenith. With this method, we inferred the first angle because we started in the afternoon. We could have done just the opposite, inferred the later angle had we started in the morning, gotten the same result. But this allows us to do it very quickly on the fly.